I might go a little bit too fast, so uh p- why say video video is on. Well, so if anybody has any questions, please stop me, okay? Agree? Yes, please. Okay. Here we go. Um if you want a review of the first three chapters, we already have that recorded, so I don't have to do that. That's the midterm review. So so tonight I'll just be starting from chapter. Well, first let's finish up the final, and then we'll do the. Um, let's go through the. Um, go through the. I think it's folder 14, right? And on. Okay, so let's do that. Um, so basically, if you know everything in this folder, you're good to go. Um, so where are we up to? Final review. Okay. So I already uploaded um, from the last class. I uploaded two videos. I didn't know which one was which, so I just uploaded both. One is about the last class, and one is about final review. Okay, so let's just go this one over here. And also, if I didn't give you a grade for a presentation, just email me and I'll look it up. Okay, so we're up to um, over here. Okay. So over here, where you see these two classes, account and account has SQL Server inside of it. So which class is dependent on which class? In other words, if you would make a pyramid, dependency pyramid, right, with the bottom would be things that the lower you go would be the most independent, right? So for example, like an N tier pattern, right? So the top, so for example, let's say you would have, so in this case over here, what would be the most dependent of these two classes? So account would be on top and then um, SQL Server would be underneath it, right? Because SQL Server, so this would be um, the top and this would be the bottom. Because the top one account is dependent on the object below it, right? So that's how we decide. And this is bottom. The bottom one is not dependent on anything, right? Well, it might be dependent on some things, but not anything in this diagram, right? Anything else in this diagram. Okay? So that's how you would read it, right? So if you were just looking at it quickly, you see that account is dependent on SQL Server. SQL Server has nothing in it, so it's not really dependent on anything else, right? Good? Okay. Again, stop me, ask questions. Uh, would we do? Okay, um, so this is basically um, we said that this is basically the strategy pattern. So the idea is that instead of having many different types of birds, you would have one type of bird and you would pass in the um, the behavior, right? So strategy pattern would just have one bird class and we pass in the behavior that changes, right? Which would be uh, what changes? The tweeting and the eating. Um, that changes, i.e., tweeting and eating. Okay, good. Good. So the answer would be we just have only one bird class. Right. Okay. In separate objects. Okay. Okay, so that in a nutshell is the strategy pattern. So instead of having a million birds, right, you would have a um, you would have just one bird class and you would just pass in the behavior that changes. Okay? Uh, okay. Okay, what's wrong with this code? Well, it says to be added later. What does that mean? So it means we're basically every time we change something, we're going to have to keep on changing the code so it violates the open close principle. Okay? Um, okay, so uh, okay, the question here is which is a valid unit test? Well, remember we said a unit test when you run it should always what? Always return true. So it should always, right. So example over here, is this returning true? Right, so this is no good because there's no automatic test, right? It's just printing to the screen. That's not good. We need something that will crash when it's no good, right? When it fails. So we need a or when it passes. So it's not automatic, right? Not not automatically tested, needs human to see result, right? Okay. Automatic, whatever. I'm not. Why does it have word correction? I don't know. So this would be the wrong with this. Okay. Let's look at test number two. Well, over here, it's always going to fail, right? So that's not good. So it's supposed to um, always pass. Um, will this will always fail? We need something that will always, will always fail. We need something that we predict, or not we predict, that should always pass, right? Correct? Okay, test number three. So this will always fail again because it's true, right? So this one is also the same problem um, because it's checking that it's false and it's always going to be true. And this one will always be true. So this is good. Yay, will always, or we should always pass. Should. This is good. Um, always pass, and that's good. Okay. And then I'll just make these red. These are not good, right? Where's red? Uh, highlight color, red. Oh, that too dark. Make it light red. Okay. Oh, what color is that? I don't know. But okay, you got to get it. This is the one that is good. So it should be green. So let's make this green. Uh, here we go. Okay. That that's good. And then this one is bad. Uh where's the put him to the color here. Okay, so the answer is the green one. Okay, this is so the answer is test number 4. Okay? Okay, everybody got that? Okay, what's answer 25? Anybody want to pipe in? What will be the answer number
Is it
25?
iterator? Iterator?
No, it's not iterator. Iterator goes through a list. What is this going through? By the way, don't be afraid of saying the wrong answer. We'll take another guess. What's it doing? It starts out at 100.
Factory?
What?
Is it factory?
No. It's a global, right? Because it's static. Every time you call it, it's giving you, first time you call it gives you 100. Next time it gives you 101, right? Because the ID gets incremented every time you call it. So it's a singleton, okay? Right? It's a global, but you can't access it since it's private. You can only access it through the get ID, right? So that's why it's called a singleton, because this is a global. And in fact, it's a global that is protected. Variable that is protected. Okay? So that is a singleton pattern. Okay? Next, 26. Okay, you understand that? Since it's private, remember, it has to be private. That's the whole point, is that the global is static, meaning global, but it's also private. So you can only access it through a public method or something, or public something public. Okay? We're good?
Yeah.
Okay, great. Okay. 26. YouTube allows many people to subscribe to multiple channels. Okay, this is again heavy on the beginning. I don't know why it is. It should be really, uh, oh, I have more stuff here. Good. Okay. I was worried there's too much stuff from the beginning and they really want more stuff from the end. Uh, okay. Um, 26. YouTube allows many people to subscribe to multiple channels. There's like which design pattern?
Would that be factory pattern?
No, observer.
Oh,
I
observer,
mean, it
sorry.
sort of gives it away. YouTube is people observing, right? So when you have subscribed to a channel, you get notified when there's you know, when there's I've never done it, but I think that's how it works, right? When you subscribe, you get a notification when something happens, right?
Right, right.
Right? So that would be observer pattern. You get notified when something happens. Factory creates decides which object gets created. Singleton creates only one object. State pattern puts the object into different states, controls what it does under different states, and the builder pattern controls factory controls which class is created. The builder pattern decides how one object is created. Okay? And this is really from the first, I don't know how it got here. Let's complete this guy. Um, okay, finally something about the end. Okay, that's too much stuff from the beginning. Match the term on the left with description on the right. So remember this has to do with architecture, right? And why is this over here? I don't know. Okay, so the presentation layer.
Is that
What is it? Which one? What first comes to mind when you read that?
model view controller?
What? I can't hear you.
Would that be the model view controller?
Wait a second, I can't hear you. Let me make my volume a little louder. Say it again.
Would that be the model view controller?
Um, no, but it's close, right? Model view controller. Does it have a presentation layer? Yeah, but wait a second. Just see, I forgot what it's called. No, there's model view controller. MVC stands for model view controller. There's no presentation layer, but it's very similar. It's nearly the same. So the answer would be the three-tier pattern, right? The presentation layer would be the top most, right?
Right.
Um, Acceptance criteria. Oh, oh, I'm sorry. This is all part of one. It got formatted wrong. Okay, whatever. They should really, I don't know. Okay, whatever. You got the idea. Um, that's all part of one. Okay. Okay, so three would be the answer for the first one. Controller layer is part of what? Well, it's pretty obvious, right? Right over here. So that would be two, right? It says it right over here. So it got to be, it's really simple. Um, no, okay. The software validation um, deals with, uh, what does that deal with?
The test-driven development?
Right, test-driven development, right? Four. And then last but not least is software requirements is number one, right?
Right.
Okay, so that's it. That's it. Those are the answers. So three, two, four, one. Okay. I love you doing Google Docs, and then I don't have to remember to save stuff, right? Okay, finally we have something to do with architecture. So over here, let's quickly go through this diagram. We have somebody withdrawing money. They asked the ATM. The ATM asked the bank database. The base, bank database. By the way, what is this called? What type of diagram?
Is this a sequence
Right,
diagram?
sequence diagram. And this is, what are those solid arrows called?
Messages?
Right, messages. And what are the dot arrows called?
Lifelines?
No. The ones going down,
Other ones?
but the
Okay.
ones going back, the return messages, right? They're also messages, they're just a return. So we ask here, and then they return this, and then they return this. And these are called these ATM bank databases are called lifelines. This is called the actor. I don't know why they give it a different name. I think I Googled it once, I couldn't figure it out myself. But why is the first one have an actor and the other two have objects? I think theoretically, the actor is usually outside the system. So the actor is, so the system starts by the first lifeline. I think that was the answer. Okay. But let me just, whatever. you don't have to, let me just look at real quick. What is the actor in a UML? sequence diagram, uh, diagram. I think it's going to say that's the person. Yeah, external entity. Okay. Right. So in the normal case, the actor is always, so in other words, but it looks, except for the, um, I mean, the actor could, it's really outside the system, but it behaves just like the rest of the system. I mean, he sends messages, it gets messages. Okay, but like this is supposed to be like the user, and the system is really only the ATM and the bank database. Right? So the actor, somebody walks up to our system, sends a message to the ATM, the ATM does its thing, the bank database does its thing, ATM processes that and notifies the customer who's outside the system. Right. So we also said that, like for example, which message would go first? Well, they actually did help us out here. They gave it a number, right? The first message would be which one? What would be the first and last message?
The first is withdrawal request and last is notify customer.
Right. How did you know so quickly that that was the answer?
Well, because it's in order. Like,
Right. It goes from top to bottom. Right. Right. Or the first one will always be on top, and the last one will be the bottommost. Right. So
right.
'cause it goes in time. So the time goes from top to bottom, and then um, the the blue things over here tell us how much time these are called the activation bar, and lets us know how much time it's active. Why it's so important, I don't know, but that's what they represent. Okay, so if we look at this, let's just make this multiple choice. Come on. Uh, Google Docs doesn't do as good job as Word when it comes to this. Um, okay, so I could tell you right away that um, E is wrong, right? E is not the answer because there's no is a relationship in this type of diagram. Withdrawal request is stored in the database. It doesn't say that. There are no return messages. There's two of them. The database is needed to withdraw money. That is true because you have to check for funds. So this would be true. And the object that takes the least time is the actor. Actually, the actor is taking the most time, right? Because he's active from all the way from here to here, or he or she. Okay, good. Are we good with this? Yeah, sure. Yeah, that's the return. Oh, going down. This is the lifeline. This is ATM. There's two lifelines which represent objects in our program. Entities, objects, whatever. Yeah, exactly. Activation, something. Let's see.
We
Uh,
don't count the actor as an object, right?
yeah, right. Yeah, I'm not gonna, you don't have to worry about that. What is a activation? I think it's called activation bar. Activation. Yeah, yeah, that's called activation bar. Okay. Yeah, okay. Just want to make sure I got my terms right. Um, okay, good. Are we good to go? Let me know if we're not. Okay, Q30. Valve usually cause code to be refactored. So we really had this before. So basically the answer is anytime you change it, or you do incremental, which means you're changing it, or you're adding new features. So it would be number 4. Okay? right? That causes code to get messy. Uh, what type of arguments will cause code to crash? Um, I don't even know what I did over here. Uh, well, let's get rid of the extra credit part of it. To what type of arguments? Oh, I see. It's just like a general question. So I don't even know. Let's say 31. Okay. What types of arguments will cause code to crash? So if you're looking at guideline, remember what's the difference between guideline-based testing? Do you remember that? So guideline is like based on your experience, right? If you want to make something correct based on your vast programming experience, right? What will cause something to crash? Well, most programmers know that if you do a null value, that will, right? Most people with programming experience will know that when you have no value or a null value, it will crash, right? Um, if you have too big of a value or too small a value, these are likely to crash. Now it's called guideline because that's based on experience, based on programmer experience, right? So as you become a better programmer, you'll get a better sense of what causes things to certain errors, right? Like for example, where I work, sometimes someone will say, "I'm getting file not found." I say, "I know exactly what the problem is." You know, I could look at the code for a second, and if, depending on the error, I know exactly what went wrong. You know, sometimes based on experience. Sometimes it takes me, I have to debug it, and sometimes even after debugging it, it's hard to tell. So, but like I think I was doing something and it kept I thought I changed the value, it didn't change. It was really weird. Anyhow, but I'm still not sure exactly why it was so hard to debug. Anyhow, but partition-based testing is more scientific. Basically, partition-based testing is like something like an AI could do, because basically you would tell the AI, um, you would say, um, this is more um, like this is easily automated because basically um, we enter the min and max um, allowed inputs, and then we uh, create the three tests below, right? So anytime we know, in other words, if I have AI program, I say, here's a method. The min value is this. The max input is this. The min input is this. The max input is that. And then give me some tests. So it should automatically spit out, based on partition-based testing, three tests, right? First, it should create a test doing that again. First, it should create test number one, which is going to test if I do less than what is expected, what will happen, meaning it should fail. If I pass in more than what is expected, it should fail. And and then if I pass in three, what is expected, it should pass, right? So this is like very, very easy to do it, right? Right? So these are actually two different things. Um,
What would you want us to have done in this question?
I'm not sure because I'm not sure it's a question. I probably I don't know if it's a real question. They just maybe just put it in here. But basically, this is the difference. This is what guideline-based testing is and partition-based testing, right? So just you should know what that is. So partition is basically, like very simple. You know what you ask as long as you know the min and the max of the method, then you should be able to create automatically three different tests, right? Right below the input, below the min, above the max, and like in the middle of the expected values, right? In our book, they actually do five tests, but whatever, but at least three. Okay. Okay. Another word for partition-based testing is edge case testing. And to be honest with you, I could be I didn't even there's not really even a question. It's maybe something I just put in here. I forgot. But it's not a question, it's just you should just know it. Okay. Okay. Um, so this is from chapter 8, I think. Whatever the chapter on testing. Okay. Okay. And then what is not true about unit testing? So So number one is this is true, right? Because that's the whole point of the unit testing is to test individual parts of the software, right? Um, a team can execute unit testing before the culmination of the development process. Is that true or false? Yeah, of
False.
course. No, it's true because the unit testing is what every programmer does, right? When they're um, as they're writing code, right? But if I write a class, then I write a unit test and I test. Remember, if you remember in class, what we wrote is we did where you write the test before you write the code. And then as soon as you write the code, you run the test, right? So it's actually this exact same time. You run the test the exact same time as you write um, it, the exact same time as you write the code. Um, okay, is that good? Maybe it wasn't so clear when I said that, right? Before the culmination development process. So way before the end, you could run unit tests. Okay? Any questions? Okay, good. Three, reduce the cost of testing and defects. Of course, yeah, that is true. Because earlier, right, that's another thing that we should mention, a simple fact that I'll just put this over here. So just as we're to know, earlier, um, the earlier a bug is found, the cheaper it is to fix, right? Because it's much easier to fix something before you release it. And then, because remember, you know, um, there's not just you write code and send to the customer, right? There's a whole big process. Somebody has to write it up. What went wrong by the customer? Somebody has to log it. Somebody has to test the fix, make sure it works. So make sure other things didn't crash when you fix it. So something that could be fixed by the developer when they write the code in 5 minutes could cost, $1,000 or maybe even more when when the when the bug shows up um, by by the user, right? Right. So a 5 minute fix, 5 minute fix. The answer is uh, as early as possible. Okay. It's more expensive to fix as time goes on. Okay, so which would be like, i.e., 5 minutes by developer versus, um, let's say, 1,000, let's say $1,000 when found by um, developer versus $1,000 when found by customer. It's actually probably even more than $1,000. It could be a lot of money. Okay, so that is, so it's always cheaper to do more test. You always save money by doing testing earlier, right? So people think, oh, I'm wasting all my money on testing. It's not true. The more you test, the more money you save. Okay. It's not really the cost of development, not testing. As effects are identified, fixed in the early stage of development. Okay. Number four, increases the reliability of the code. That's also true. Allows for interact testing interaction between various parts of the code. So what is wrong? Which one is wrong? They all sound good,
Five
right?
is wrong. I think.
What?
Is five wrong? Allows for
I'm
testing.
sorry?
Isn't the last one wrong?
Yeah, that one's wrong. Why?
Because unit testing is supposed to be for individual parts of code. It's not supposed to be
Right.
for any various part of
Right,
code
right.
base.
Number five is really component testing. Though, there's a whole big argument about what is component testing, what is unit testing. I actually saw a website. I wanted to show it to the class. He argues um, that unit testing is it's actually doesn't mean unit testing means code which has no dependencies versus code that has dependencies. That's how he defines it. Whatever, but the way we define it in the book and most people define it is number five, okay? Just if you're interested, you could look it up that there's this guy he has an alternate definition for component testing, right? I'll put that into parentheses. And what's the level of testing after this? What's that called? Do you remember the next level of testing?
Is it integration testing?
Well, I'm not sure. Integration is basically five. It's just another word. Integration, component testing.
Oh, component testing.
Yeah, what would be the next level after that?
Is it user?
No, there's one in the middle. One more. End-to-end testing or system testing, right? Right, there's five levels of testing, right? There's um at least in our class. Again, depends on your company. So there's five level levels of testing. So the first would be unit. Um, um, A would be unit. B would be component um, or integration, as you said it. And then three would be a system testing or end or slash end to end. No, you test the whole system. Then you would have release testing, right? Which is different than C because we're testing for features, right? So over here, the first three, we're looking for, um, why does it do that? The first ABC is testing for bugs. Release testing is making sure all features are there. And we also said it should be done by a non-member of the development team, should be done by people other than the people who wrote the code. And then finally, we have the user testing or acceptance testing. Okay, that's done by the user to make sure that it works the way they want it. Okay? Okay, good?
Yep.
Yeah, it makes sense, right? It's logical. Okay. Which architecture is associated with a web page? So a layered pattern. Okay, I mean you could say probably any of them, but the one that's most closely identified, we said, was the model view controller pattern, which is oh, I'm sorry. It's client server pattern. The model view is for a web server, not a web page. Is for a the truth is they probably be okay on a test. I probably give you credit for either one. But this is actually this is for a web server. Okay, meaning the program running on the server, right, uses a model view controller pattern, but the web page uh, uses a client server um, architecture. Over here, pattern doesn't mean design pattern, it means architectural pattern, right? Um, I don't know why I started counting again, but um, this should be not, this should be, no, what is this doing? I don't know. This is weird. Uh, this should be A. No, they not as good as Microsoft. Yeah. By the way, this is an amazing program because I think this is all written in JavaScript, right? They basically rewrote the whole thing in Java. I'm pretty impressed um, with Google Docs. Okay, which architecture pattern is associated with an email program? So we again that would be client server. It's the same answer, right? Because usually an email program, the client is on the your desktop, and then there's a server somewhere, right? In the diagram below, so you have A, B, and C, right? S- Uh, so what would I don't know why you have the cloud in there. What does this look like?
Is this client server?
No, client server is only you only have two things in the diagram.
Oh, this client. Well, there's a database, there's a server, and there's a client
Well,
compute.
this is the three-tier pin, right?
Oh, three
Because the
tier, right?
database, business logic,
And then
and presentation
presentation.
layer. I guess I should really take out the cloud, but ignore the cloud. Uh, I'll just write that down. Uh, A represents, oh, uh, note, ignore the cloud. Let's keep it simple. So A would represent what? Number one, right? The presentation layer. Okay? I guess you would have figured out anyhow because you would have had to pick from these five choices, right?
Right.
Okay, so that would have been. What does persistence mean, by the way?
The data stays, like it's like long-term data, so it's not.
Yeah, basically three and four are the same. Just another way of saying it. Okay. Um, which type of testing would a developer probably do? Well, black box, oh, actually, I explained it. So most probably they would do the white box because the black box, means that they don't know the code inside that they're testing. White box means they know, so it would be probably white box. Acceptance done by the client, release is done, somebody's not the developer, and this is probably going to be done by somebody, a graphical artist, right? Did I say that right? Graphical or a graphic artist?
I think either works.
Yeah, graphic artist. I don't think it's such. Okay. Um, if I want, this is just, okay, I wouldn't ask this again, but no, if you wanted to test this to see what happens, what, um, what, which value below would crash it?
Is it 0?
Right, zero, right? That's always the best thing. If you want to crash anything, enter a zero, right? Right? So you see what happens if you pass in zero, if it can handle the zero, right? I think, right, okay. By the way, Java, the IntelliJ Java, it's very hard to crash. I don't think I've ever crashed it. I mean, they basically, the programs don't crash. They somehow get handled very well. So it's very hard to like actually kill a program. You know what I mean? Um, in C sharp, I think it's easier to crash a program than it is in Java. Okay. These are all from the midterm. Uh, okay, get rid of that one. I will go over it anyhow. So ethnography is basically, do you know remember what that is?
Is it user culture?
It's basically it's like it's the it means like understanding the environment, the social environment. N not social, but like the yeah, I guess it is social. I mean, but it doesn't mean like social. It means like yeah, just say the environment. Nerds like, is it going to be like used by kids? Is it going to be used outside, outdoors? You know, stuff like that. Um, So it's more like just because you did all the requirements, but maybe the environment it's going to be used um, is not good for the way you designed it. So for example, if you have a program that uses the internet, let's say Google Docs, which I think stores everything on the cloud, right? So that won't work too well if you're flying on an airplane, right? Where there's no internet. Okay. Or let's say you're in a space rocket and you're trying to use Google Docs, you might have a problem, right? Where your program, okay, so saying like even though everything you did was 100%, you did everything correctly, but if you don't know where it's going to be used or right, then it still might not be good enough, right? Um, you know, might be used by people going on a hike somewhere and all they have is, you know, oh, just very little internet, right? Self-revolution, that means um, uh, new versions, maintenance. You should know all the diagrams. Um, oh, it could be ethnography is in chapter four. Oh, it is in chapter four, I think, right? Or is it in three? I think it's in chapter four. Oh, that's why I put it in. Okay, self-revolution means, but this is from chapter one, means new versions, maintenance. The diagrams, you should know all the diagrams. Um, right? Do you remember all the diagrams? What are they? Well, we'll see well, basically, see, I think that's chapter five, right?
Yeah, that's chapter 5.
Chapter five. Okay. Then the difference between state, okay, this is a question that's asked is what's the difference? Um, oh, Oh, this is, I'm sorry, I got mixed up. Difference between state and activity diagrams. So what's like a major difference between the two? So activity shows you activity between um, different objects, right? Or different activities, right? You go from one activity to another. But state diagram is telling you, is focusing very closely on just one object, and it's telling you the different states it could be in, right? So there's a huge difference between the two, right? Activity is a very high level, state is a very low level, right? And a sequence would be somewhere in between the two, right? Because sequence is telling you messages between objects. But activity is not really discussing objects. Let me just write this. So activity, which shows you the the order of activities, right? It's not even discussing objects, right? This is
Right, right.
just the activities. And the state focus it, so it's high level. And then the estate focuses on one object. So this is very low level. It's probably the lowest we could get, right? I think, right? Because telling you all the different states or values, I guess. So this is it's where we're just concentrating on one object, and we're telling you what are the different states it could have. Okay. Though in our book, this is the way I taught it. In the book, it's a little bit more general. So they have like the state of a washing machine, the state of uh, but I think really it should just be one. It should be pretty limited, or it's kind of worthless, right? In other words, you can't okay, without getting into it, but that's or one object should be limited. Now, there shouldn't be like 50 states something can be in, because if it's 50 states, then it's probably not a state diagram, right? It's probably more like what the object is doing rather than what it is, right? The state says what is the object, right? Like, for example, a car could be in drive mode, or could be like, for example, the engine could be in two states, um, on or off, right? Of course, could have the engine could have something broken, engine could have the oil leaking, could have transmission fluid leaking, but that's not a state. That's really just that's not really the state of the object. It's like a um, that's more like something else, okay? That's like something happening to the object, but I wouldn't call that a state, right? So it should be more or less a high, it should be like only a couple values, okay? Like in the book, I think they have like a microwave could have the door open state or closed state, could have the power on, power off. But I think that once you get that far, it's not really a state diagram anymore. It's more like an activity diagram. You know what I mean? It's not really a state of the object. The state would be like, is a microwave on or off? You know, a door is either open or closed. Those are states, right? When you add too many things, it loses its meaning. Okay? So for example, water could just be H2O could be either water, vapor, or ice, right? It transitions between them, right? Object transitions between states. Okay. Multiplicity, you do not have to know. Pipe filter is an architectural pattern. Does anybody remember what that does?
does it is used for structuring systems that process a stream of data?
Okay, in English.
Oh, um, is it takes a input and performs like a transformation, basically.
Yeah, and then the output goes to another program, right? So
Yep.
it's a string of programs. I mean, in there, normally it's the in one it's a bunch of programs of separate programs where the input of one is the output of the other. Okay?
Hmm.
It's basically so it's a bunch of programs, but they're separate programs, right? Which is what's nice about it is so when you change one program, you only have to look at the input output, the rest you don't care.
Hmm.
So it's very nice architecture. Like you can't break, if you're only looking at input and output, you're not looking at anything else. Um, so, like I was saying with compilers, right? You could buy, um, like for, I mean, I remember when I was doing C programming, you could buy different linkers that were, so you could use part of you could swap out the programs as long as they have the same input and output as the one you're replacing, right? Okay. Yeah, so I remember like when I was used to program in C, they sold different linkers, they claimed to be more efficient, whatever. Yeah. Like nowadays, typically when you release a program, it has a lot of garbage inside of it. Did you know that? Like for example, we don't care that much about it where I work because we want to have all this uh, debug information inside of the program. So for crashes, it's easier for us to fix. But in reality, it could really be much smaller if if we didn't have all that debug information in it, right? But nowadays people don't care so much about speed because it's because we have quick. I mean, they don't care so much about size of the EXEs because we have fast CPUs. So, but where I used to work, you would make. I remember when I did C programming, you would have a release version, and you'd strip out anything you could get rid of. Okay, so you would buy special linkers, which would either they would make the code really small or very fast, right? They were optimized. Like, for example, Microsoft, when they sell Windows, their main issue is speed, right? So they want Windows to run really fast, so they have special linker which gets rid of unnecessary, even loops, I think they probably get rid of, you know? Like they figure out ways to optimize the code execution, right? I don't know how popular, it used to be more popular when CPUs were slower, right? So there's something called an optimizing linker or something like that. Remember that. Let's see if they still have it. I don't know if they still have it. So, but it used to be called a optimizing. So it would squish the most performance like linker. So I don't know if they still have it. Okay, yeah, so they still have this idea. I don't know where they use it. Uh, yes, they have in C++. Okay. So, but that's the idea, is that there are different people that have linkers that specially do that. They look for a place, they look for ways to make code run faster. Okay. When I was doing C programming, when and computers were a lot slower, that was a big thing. Okay. Number six is saying static means global. We already said that. Go through, review the process diagram. Right. Remember that is? That's one of the diagrams, right? Or process or activity diagram. So that would be something that looks like this. Um, okay, just look at chapter 5 again. You just look at the notes for that. See chapter 5. Meaning chapter 5 in my notes, not in the book. Or you could see in the book. See chapter 5. Web browser is always client server because that's really what the definition is, right? Definition of a web browser is that it's client server, right? It's making requests, it's getting requests and responses from a server, right? Right, from a web server. Okay. Oh, I'm sorry. I'm actually not tired. Um, okay, 9. Remember which non-functional specs require which architecture? Oh, right. So we said that this is from chapter, I don't know, the architectural chapter, architectural pattern chapter. So they say that if you need performance, right? You know, the things on the left are all non-functional requirements, right? They're all like general requirements for the for a program, right? So performance, right, is so if you need performance, which means what? Speed, right? So code should be together, meaning on the same platform, meaning you shouldn't have, let's say, two computers that rely on each other. One computer relies on another, two systems, right? It should be all in one system, right? Like, for example, where I work, we have an accounting system and we have another system, right? We have different systems. So if you're worried about performance, you shouldn't rely on other systems, right? You should have everything, and also you should probably have things um, on the same program, computer running together, right? You shouldn't be relying on programs running on other programs, right? Um, Running somewhere else. Okay? Don't. Why does it do that every time I do it? Annoying. Uh, okay. So if you're worried about performance, so don't do that. If you're worried about safety, then meaning that you want to understand, you want to like like AI doesn't like from what I understand, they use Tesla started using AI for deciding how to drive, but the problem is you can't really debug AI, right? You can't actually it's more difficult to understand why it's making decisions or how decisions will be made, right? So even I think AI works better than when you understand what it's doing, but it's not as safe in a way because you don't really know why it's making decisions, and therefore you don't know when it's gonna break, right? So, so they recommend the book. If you should have the code be easier, instead of rather the code, the logic being spread out throughout the program, you should put it in one place, the main logic, so you can analyze it and make sure that there's no, it's safe. Okay? Are we good so far?
Yep.
Okay. So. Yeah, like if you had a pacemaker, right? You would want to know, you would hope that they knew why it did what it did. Not just like, oh well, like Tesla seemed to crash a lot. So because they're basically, they only work for situations that have already if using AI, it's based on situations that they've been in before, right? But new situations, it doesn't know what to do, right? Unexpected situations. and it's always going to, right? So that's why it's self-driving is probably never going to be, 100%. Okay. On the other hand, it's probably still safer than when you. It's not like when you fly an airplane, right? It's safe, but when something goes wrong, it goes really wrong, right? Like, the plane doesn't just crash. It crashes for no reason, Like like a plane all of a sudden is taking off and just takes a nosedive for no reason, So because something happened that was unexpected, that no one thought about. So that's the problem. So it's for safety, you would want to be able to be able to review all the code to look for flaws, right? As opposed to, well, it hasn't crashed till now, so you know, but that doesn't work in the real world where things change. And a pacemaker would be a big example. Like you might have designed it you might have tested it on, let's say, 100 people, but they're not representative of everybody's heart. Like I know somebody whose regular blood pressure was like 40, like like or 60, like very low blood pressure. That was his regular blood pressure, you know? So, so somebody like him, like probably a pacemaker might be dangerous, because they're not designed for people like that. Okay, security. We said you should always have the top, you should have layers, right? Layer, layers with a top security layer on top, um, requiring authentication, right? So we don't let anybody in. No, it's not like, like sometimes you have an apartment building, and you let somebody, or let's say you have a building and you let somebody walk in, and then after they walk in, then you check but they're already inside the building, right? No, you don't even let them in unless you already check them out a little bit, right? So that would be like Queens College. You can't even get past the front gate unless, or it used to be like during COVID, unless you had a Queens College ID, right? You weren't allowed to enter unless you could show them your, or for a short while, right? I remember they had that. So, um, so that would be the so then you can't even get in until your Queens College Road. Then what what building you could get into, what office, that's something else. That would be authorization, right? So, or maybe there would be further authentication. Okay. And then maintainability is making code easy to change. And if you want to make code easy to change slash fix, right? Well, how would you do it? You would use very small amounts of code, right? Because the smaller the pieces of code are, the less chance you're gonna uh, make a lot of bugs when you make a change, right? Because it doesn't do too much, so it's safer and it's also easier to understand, right? Are safest to modify creating bugs because they do less and also are easier to understand. It doesn't mean you can't crash the program, but it means at least like what I don't know. I mean, you still got to be careful. I mean, you could always crash a program making if you don't understand what you're doing, you could always crash it, even if it's a small, you know. And another thing yeah, okay, it's not okay. I'll leave that up. Okay, Scrum. We went through this. You have the product backlog, wish list. You have the backlog, potential release candidate, daily stand-up. Okay, we did all this before for the midterm. Uh, we said that all these are the same, and remember all these ideas: solid, preferred compositions of inheritance, You know all these? Remember these from before?
Yep.
Solid is basically S. It stands for um, single responsibility principle. You could look it up. O is open close principle. Single responsibility means that what? The code should only do one thing. O means open closed, meaning that the code should be open for um, for op open
Open for
for
extension.
extension, closed for modification. Okay, very good. Thank you. L stands for what? Liskov substitution principle, which means that you should be able to, when you use a child of a parent, you should expect the same behavior for the same methods, right? Now, as if you have a child of a object, a child should not get different behavior for the same method that its parent does, right? I stands for, right? Remember that? It's a simple idea, right? Right? Because you could always replace a parent with its child, right? So we don't want a child to, so since they're interchangeable, the child and the parent, we don't want different behavior from the child than the parent, right? For the same method, okay? That's Liskov substitution. I stands for integration principle, which means basically don't put too many things together that don't belong because then you're messing everything up. You're causing a mess. D stands for dependency inversion, which means that you should always use the um, most general type. And in other words, whenever you have a choice of which type to use, you should always use the most general possible. Obviously, not don't go crazy and just make everything an object because that's kind of useless. But but if you could be more general, then you should be. Okay. It's always use the most general. The dependency version says always make your code as general as possible, right? Because the more general it is, then the less need to change it later on, right? It's a simple idea, right? If you make something very specific, right? So, for example, if I have a job opening for only people who are 6 feet tall, I'm only going to get certain people, right? Tall people. But let's say the job is, washing the floor. Do I really care about how tall you are? So I should be as general as possible, all right? In fact, I might even hire a robot that washes the floor, right? So my job description might be I need something or somebody that could clean floors, right? I don't care who does it, right? I'm not, I just need something that washes floors. So I don't, it doesn't have to be a tall person, doesn't have to be a person, doesn't have to be could be a machine, could be an animal that's a trained animal that could wash floors. I don't care, right? Could be a floor that automatically washes itself, right? All I want is a clean floor. Okay, Yagni is solid is 5 different principles. Yagni is one principle, which stands for you aren't going to need it anymore, which basically says get rid of code which is not being used. Okay, because it just muddle it just adds clutter to your program. Dry means to um, uh, don't repeat yourself, and this is an idea which is that you want to have all the logic that does one thing in one location. So when you change your logic, you're changing it throughout the program. So you don't have to worry that you change in one location, not the other. And then prefer composition over instead of inheritance. This is a general idea where we don't like inheritance because inheritance is too strict on the children. Okay, so since a inheritance is of a child is the same as a parent, then the child is being forced to do things they might not want to do. right? So, and then they have to fight against it, and then the code becomes very messy. So it's better not to use inheritance to, if you want to reuse, if you have an object that you like some of the stuff inside of it, so then you should make it part of your object rather than inherit from it, right? Right? It's sort of like, if you have a friend and like for example, let's say I need something I need somebody to do something for me. So um, it's a lot easier if I only need like a couple things from that person, then let's say I need a certain project finished in a month, and after that I don't need that person, right? So rather than hire them as an employee and then I'm stuck with them, right? And have to fire them and all that, right? Pay their insurance and all that. I should hire them just for what I need, which is a month. So I should say, hey, could you be a consultant for a month, right? So I don't want to, like in this case, I don't want to be, I don't want to be too tightly coupled with you. I just want you for for one specific month, and then after that, get lost rather than and then let's say hiring you, and then I'm sort of like more stuck with you, right? Then I have to pay for your insurance, your workers' comp, and I have to fire you, and then you'll take me to court for firing you after only 1 month for no reason, blah blah blah, and all that. So, and then I have to give you severance and all that. So basically, it's always easier in general, it's always better just to have a loose relationship with things, right? The more tight your relationship, then then you're stuck with it, right? Um, right? So, um, so you find in business all the time, by the way, in all different things, right? That businesses would rather outsource things rather than being stuck with it, right? Like my company, they outsource, let's say, a lot of the human resource stuff because if they're not happy, they don't have to fire anybody in the company. They just get a new company to do whatever the other company did, right? It's easy as just firing, stop paying one. It's more expensive in a way, but on the other hand, it's cheaper in terms of you're not stuck with that. You're not like, dependent on any um, uh, provider, right? So that's why companies like consultants because they're not like stuck with them. Even though consultants usually in the short run cost more money. In the long run, it's just easier for a company to deal with, right? It's not messy. They just say, okay, you're going, goodbye. We'll see you next. You'll see you. We're done. Find someone else as your client. Um, okay, so that's the idea between of composition and seven inheritance. We want to have a weak relationship between objects. The stronger the relationship, the more things go, the more messy things get. And companies don't like mess. They like things to be, they don't want to be involved in, litigation, messes, stuff like that. They just want things to be easy. Right? They want to concentrate on their work rather than, you know, we're stuck with this person because we hired them for a 5-year contract. I mean, it happens with teams, right? Sports teams, right? They hire a guy for 10 years, and then the guy, I don't know how it works, but then the guy starts performing badly, and then they're stuck with that person, and then you know, they have to trade it to some other team. Yeah, I don't even know how it works, but I imagine it's a nightmare when you sign a 10-year contract and the person ends up not being worth 10 years. Um, okay, different thing. Aistic interface, that you don't have to know. In fact, the similarity is what you should know. Similarity is that both of these types are uh, between with is that they um, are very general, which is good, right? abstract and interfaces are very good because they are very general, right? They're extremely non-specific because they are very general, right? And we said that the less specific you are in programming, the better you are. And we're done with this review, even though we did a lot of things that weren't on the final. Okay, but it's a good review. Okay, so I'm going to take a 10-minute, 5-minute break, and I need a drink of water because my throat is sort of dry from talking. And you guys want to keep going? Yes, no, maybe. Well, basically, all I'm going to do now is go through all the chapters quickly. Are you interested?
Sure.
Okay, as long as some people are interested. Okay, so I'll just take a 5-minute break. I'll be back in 5 minutes. I'll just stop recording. Just remind me to re continue recording. And yeah, as long as you